surface or it doesn't?
Are you stupid or something else?
Are you not understanding the question or something else?
Okay. I think you are saying, you ask me, do you have a surface? That's a very, very stupid question. So, of course, I have a surface. It's my answer.
Geometrical physical surface. Do you have that?
Yeah, and the surface. If you're looking in the distance, with from the surface you're standing on, and you have the sky below, not below, above. I mean,
it's above.
It's above, and it will meet together in the one point in the end.
Yeah, it meets where you're standing at too. So I don't know where you're getting with that. That means nothing to me at this point.
What are you talking about? I'm standing. Okay, looking out over the ocean.
Okay, over the ocean. Why not? Sure. Okay.
There's nothing in between. Nothing. No mountains. Nothing.
Got it. Okay.
So, and you can see it. The sky and everything. It gets smaller. Everything gets smaller in the distance.
Wait. What if there are no clouds in the sky?
If okay, it doesn't matter.
I think it does.
Okay, of course, it's better to have reference object. We call it to the perspective.
What's your point of reference here?
You need a point of reference.
Seagull
to understand.
Right.
We'll just use a bird for now.
Maybe one bird, but do you know? One bird was flying. They were taking, zooming.
We'll call it
into the moon. It was just like one bird was flying over the moon.
Perfect. So a cow jumped over the moon.
It can be very, very.
Well, the ceiling ramps down to the floor. We know this, but we need to see if it's cutting off images over a flat plane.
Yeah, that's still not how that would work, dude.
Why not?
Because according to you, the ground arbitrarily stops.
Because you're only 6 feet off of the ground. And that's based off of your sight-liking symmetry.
Hold on.
Similar activity from all directions.
Hey, Lemon, you said
Lemon's thinking about straight lines, though, see?
Yeah, Lemon,
so based off of...
Wow. I was going to say, you said the same thing about somebody in an airplane. You said the same thing about people on top of mountains. You're saying that the floor arbitrarily stops obeying the principles of perspective.
So it would rise toward the level of the eyes, not perfectly at the level of the eyes, depending on how far it is from your eyes.
You're still ignoring what I just said.
Why don't you repeat it? If you don't repeat what you say, I tend to think that what you're saying is pretty unimportant and easily ignored.
Yeah.
What were you saying?
Why does the floor arbitrarily disobey the principles of perspective?
Which principle? Are you saying that it has to meet at the level of the eyes? Is that what you're talking about? That's because you're dealing with a surface that is below the level of the eyes. So what are you talking about?
So then how does something that is, as you said, below the level of the eyes go above objects that are on it?
It doesn't.
How does it block?
Things smash towards the level of the eyes and you can't tell what the hell is going on.
The floor would do the same thing. So again, how are you saying?
So you can't tell what is above or below anything because of the level of smushing and smashing. That's the point.
No, it's still not how that works. You saying
why not?
How are you sure that that's it?
All I'm sure that that's the answer. Questionable optical theory and no basis. What other than makes sense?
Well, I mean, it's the opposite though. Like for some people, I mean, you understand what you're trying to say, but for us, it seems different. I guess.
You think you're slick?
Way to put it.
Well,
Yeah,
everything here smash toward the level of the eye, so you can't tell what's above or below anything. It's just a bunch of
No,
information that's smashed.
not really. It's still
How
just
do we
angular
demonstrate
size
that,
change
like,
over
to show
distance.
that that's really a thing? Like,
Reiki
because, I mean, you
shows
can
something
show.
disappearing bottom up over a floor. How about that?
Oh my
Third
God,
floor.
so have I. What's your point? I've done it on a table, and I know how it's done. Are you
Now
going to
here's the thing
say
about
that?
there's Pebbles on the Pond has done a demonstration where he sets up little items and moves 300 feet away and sets the camera on the ground, and he lifts the door and lets the cold air in, and sure enough, it creates miraging and obstruction. But before he lifts the door, those little items 300 feet away on that flat surface, you can see every bit of them. So that negates that.
Except for the laser on the left-hand side that's sitting on the floor
Yeah.
that he has turned on, that you can't see it because it's that area that he sets them in is a slope.
Ah.
That's why.
What a fucking guy.
So the ceiling and the floor ramp up together. That would lead one to logically conclude that the visual information will eventually smash together into an unresolvable line.
But if the floor is
No.
sloped, though, that's not what it does. That's not what we're proving there at all. What we're proving is the guy is willing to lie for a side of an argument that he clearly doesn't even believe in anymore. Because if you're lying,
Nope.
you know you're not, you don't really believe it anymore because you have to lie.
It's a combination of the diffraction limit with refraction making things pop in and out of this diffraction limited line of horizon. That appears to be the combination.
Lemon.
I remember demonstrating that as an artifact of the camera.
Hey Lemon, can you get me unbanned from your guys' server so I can come in there and shit on you guys some more?
No, if you're not going to answer questions and be stubborn, you can kick rocks. Be well,
That's
though.
it. So he can't actually challenge you, but you
That's
have
it.
to
Have a
do
good
what?
life on the flat plane.
Hmm.
Lemon,
The
are
flat
you
plane, huh?
disagreeing? Are you disagreeing that perspective is angular size change over distance?
I agree with that. The thing that I disagree with you is where the vanishing point of the object is if you're dealing with a mountain, a tree, or a building, something sticking out of the flat plane. The vanishing point would
Things
tend to
don't
be toward
have
the level of the
individual vanishing
eyes.
points. Lemon, things don't have individual vanishing points. That's not how that
You
works.
need to establish where the vanishing point is to figure out what its disappearance behavior is expected to
Lemon,
be.
you know where the vanishing
Out
point
of your
is.
theory, you don't establish where the vanishing point is on the object.
You don't.
What's a-
That's not how that works. You don't have vanishing points on objects.
That's what you appear to have with stuff that's parallel to the ground and going in a parallel direction to the ground.
Yeah, the vanishing point is wherever you are. So where your head
Objects
is.
have a vanishing point. It appears that
No.
visual zones have a
No, they
vanishing
don't.
point. You need to establish where the
Lemon.
vanishing point is. On that
Lemon.
building sticking up out of the ground, where do you think the vanishing point is?
Lemon. That's not how
I
that
have to
works.
ask you this question to see how you think about the problem and test your theoretical basis. If you can't even answer this question, you are not equipped to even handle the problem. Where is the vanishing point on the building as it goes away in the distance? I would say that it's toward the level of the eyes. Where would you say that it is?
It's nowhere.
Lemon Bird.
This is why your theory is shit. You can't
vanishing
establish a basis of where the vanishing point is on the object.
Are you listening?
No,
Objects don't
because you're
have
not
vanishing
willing to
my
test your
father.
own theories. I'm not going to be on the hot seat forever for you when you're questioning me from your questionable fucking base.
They don't
That's why I put you on mute. Stay on mute.
I wish you would.
Oh my
I wish you
God.
would find your level just like water finds its level.
It's just weird.
You think he left?
Yeah, I knew he was leaving.
He literally triggered himself. One day, flat earthers will also find their level, right? One day. Not today, but someday.
I really don't understand why he thinks that a point on something would disappear due to some diffraction limit when really, like the Rayleigh criteria, it pertains to the whole object, not just part of the object.
I don't know. I don't know enough about all that to really comment on it or know anything about it, but I just know that when you look out at the fucking ocean, things go underneath everything.
You
So
gotta
obviously they're
remember,
going over something.
on your ball, you're smaller than a microorganism.
Oh.
Like if you
You're
take
going-
the size,
Yeah.
if you take the size of the universe and then your size that you are and the world that you live in, you are so small that nobody can even see you.
Yeah.
You know what I mean?
Yeah.
It's kind of like showing someone an apple and them arguing with you that it's not an apple, it's actually a pancake.
Oh, flat earthers love apples because they float in water. Oh shit!
I wanna say
Before he
that,
left, I should have asked him. Should have asked him what keeps us on the Earth. I've been asking all the flat earthers that lately. It's always density and buoyancy, and it's always fun to hear. They're
Did y'all hear Whitsitt a while ago talking to that surveyor?
Yeah, Whitsitt's an ass.
Man, that was like, I mean, I don't know how much more proof that you need that that your geodetic surveying doesn't prove shit when you have an actual surveyor come on here and just tell us that the metadata is he doesn't have access to the flat Earth metadata. Did you notice that?
Yeah,
What are you talking
the
about?
Whitsits and Sin Cleanser and Mabbits, they don't ever do anything. They just say something is wrong. They don't know what the right answer is, but they know that the measurement of the planet for centuries is all some sort of like circle jerk where everybody just agrees on some sort of crazy lie instead of trying to prove the other guy wrong. And they've been academics try to prove the other guy wrong. They compete.
I don't think I've ever seen anybody argue with evidence in support. They always try to just poke holes. And if you try to talk about flat Earth and getting proof of flat Earth, the conversation always goes sideways.
their only proof for flat Earth is what they feel they can disprove about globe Earth. It doesn't make
Right.
any sense. And like their reasons for disproving globe Earth are literally half-baked scientific ideas because they've never had any formal studies in anything other than fucking like YouTube. You know, like they just watch YouTube videos and they're
Stop
like,
generalizing
"Ooh."
so much.
Yeah, like when Whitsitt
it's
was
true.
questioning when you have multiple measurements and they're all very close to each other. Very close to each other. Not exactly the same, but very close to each other. Yeah, you have statistical validation of taking a mean and assigning a plus minus range. And out of his mouth, he says, "See, that's like completely fabricated." Well, what the hell? Even if you had like the world's best micrometer and you're measuring ball bearings, you're going to measure the ball bearing 8 or 10 times, get slightly different values, and then come up with the average, right? And yeah, if you're measuring with a laser, we love lasers, and you measure it over and over and over, you get a range that may vary well behind the decimal point, and every one of them is as good as every other one. So yeah, you average it. Now, if you have one which is like a meter different, well, obviously you ignore that one. But in the hundreds of measurements I've made, I have found so few that are just slightly out of range and not statistically far enough to be discounted. Yeah, so at 27.7 miles away, I calculate the elevation of the tower and apply all the known physics, of which I have verified by my own measurements, because I didn't just measure from 27 miles away. I measure from 24, 22, 20, 19, 15, 10, 12, 8, all the way down to and including 1 mile away. And from 1 mile away and 27 miles away, yeah, there's a difference, about 1.5 feet. Now, considering the tower is 400 feet higher and 147,000 feet away, and I get within the same less than 1 meter difference.
Are you done?
Yeah, after applying 500 feet of curvature in the plus and 80 feet of refraction in the minus, and I do that all through the valley on all the other 20 points,
Are you
and
done
it
now?
makes a beautiful looking, statistically satisfied curve, of which returns 522 arc seconds per mile, where the angle gets lower than just the right triangle. And
Hey,
that
Larry.
exactly matches the 100-year-old
Let him finish.
textbook. That exactly matches a 100-year-old textbook. I call that repeatable science.
I call that being long-winded.
I call that measurements and observations. What do you call it?
Measurement
told you.
and observations.
Hey,
And anybody
Percentage-
can do it
Percentage, did you hear
anywhere in
that
the world.
interview with Whitsitt?
No.
You missed it, man.
Who was interviewing him?
He geodetic surveyor. But
Did
I
you
can't even
demolish
believe
him?
that. Oh yeah, they shouldn't even let that guy on here.
Oh, what
That was
happened
rude.
here?
You're right
And
here.
what
just
was-
a
what
little
was-
while ago.
And what was Whitsitt denying about the geodetic surveyor? What
Everything.
was he denying? Of
Did
course.
someone
No,
grab a
he-
clip or
He's
something?
because he's never done it, right? So he
Yeah,
doesn't know
he
what
had
the
no
hell's
tech-
going on.
Oh, and then earlier, I don't know if it was Chemo or whatever, said, oh, the only reason my measurements make that appear to be right is because I believe in gravity. And so since I didn't make independent proof of gravity, then the fact that I measure from the gravity vector, the plumb bob. Yeah, I measure from the plumb bob. And yeah, two plumb bobs hang not parallel, but radial to the planet because the South Pole exists. And they dance around the South Pole, and you get that ultra idiot Lemon carrying on, the ice wall, completely unobserved in any way, shape, or form. That's more likely true than the South Pole, which thousands and thousands of people have gone to. Because we have a dome. Now, how far is it? Well, we don't know exactly, but we know that the globe is wrong. Fuck them.
Larry, what would you say? What do most of the manuals say about doing the surveys of large areas?
Well, in surveying of a large area, you have to define large. You have a large area like a big farm, or a large area like a small city or a county or a state. And so when you're measuring,
let's say like a small town, let's say like 40 miles.
yeah, generally they run the engineering department will just have their own horizontal grid at their elevation, because it makes for small numbers, and any surveyor can go out there and make measurements which fit directly into that grid. And the X and Y are in fact what they call plane surveying, because you're only dealing with a couple hundred square miles. All right. But the elevation factor is still always related to the radius of the Earth without fail. So they want to carry on about level
Only if you
and
presuppose
horizontal
a globe.
being the same, but yet they have absolutely no experience or technical expertise if they had to deal with a sanitation draining system, or a floodplain map, or the elevation of water towers, or the elevations of bridges and shit, where you have to use vertical angles at some significant distance of a couple of miles.
Yeah, the video I
Sir,
just
Larry-
posted is
Larry,
like
really-
Sir,
the video I
excuse
just
me.
posted is literally like
Don't worry,
describing
guys,
all
I'm
of what you
back.
just said.
No, not you.
Larry,
the
what-
other
and-
guy.
Hold
The
on,
other
hold
guy.
on. And Larry, what would
I
happen?
will ask you.
if
I will
did
ask you. I will
No,
answer
John,
you.
hold on a second, Johnny. Hold on.
Okay. Okay.
So
No
what
problem.
would happen, Larry, if for instance we were doing all those surveys and you didn't take curvature into account?
Then I get a chaotic array of values for the elevation of a distant object. They're all different, but they're all different by an
Your bridge
exact
would collapse.
equation. Exact equation, plus or minus.
Which
an
bridge
error
would
bar.
collapse?
All of them. You have to take into account
Oh,
curvature
sorry,
in the
that's not
equation
true.
when coming up with the elevation for another point.
Yeah, that's not
Yeah.
very true.
It is just a fantasy. There is no ground for it.
How is it a fantasy? That's what
There
actual
is-
surveyors use
Oh.
when they're determining things. Civil
There is
engineers.
there's no
I've
real
never seen one. I've never
authorization
seen a
for it.
surveyor. Look,
And
I'm a
again-
baller.
You've
I've
never seen a
surveyor
surveyor? Okay.
And
say that
okay.
they had to use curvature of the earth to build a
And-
bridge because the joints
You,
in
you
the
have to
bridges, the
understand.
pieces that go together
Because
have
it
enough
depends
play
on
in
what
them
type
to
of
cover
bridge.
for any coverage, for any curvature that there might be. So they don't need to actually do that because the bridge will automatically conform to the shape of the sizes. The pieces of the bridge are straight. The connections are where the bends are, and the bends do bend occasionally, but they don't need
I
to
guess it
take
depends on
into
what type
account
of bridge they're
curvature
building.
for that. Yeah, bridges are built in sections.
Uh,
Any modern
it-
bridge is now built in sections.
Yes, and we have to understand what is observation, what we can see, and what we can test, and what we can measure. And we have to keep it in mind, and we have to question it. Everything that they say, if they say, "Oh, it's 20 or maybe 7 light years ago away." Oh shit! It's too much.
Yeah,
Do you ever think
Oh,
about that, like in movies when they do time travel and shit, that they're like they still land on Earth? If Earth is moving and blah blah blah, and they really went back in time, wouldn't they land somewhere out in space?
Yeah,
Just thinking
it's
about it.
impossible. So we have to be talk to each other and understand what is possible, what is not possible. Not living in a fantasy science fiction movie.
Hey, John, what qualifies you to make those decisions?
A human being.
I'm a
I have
human
a
being.
Not
I
considered
have a
portable
time
brain.
travel machine has an
I have a
amazing
phone.
magical
I can-
calculator that calculates
I
exactly
have-
where the Earth is going to be at the time you travel to.
What has
You
two
guys are
thumbs and is
basically saying
qualified
that
to talk
all-
about this.
You guys are basically saying that everyone that works as a geodetic surveyor is a liar, and like they're not. They have
Of
no
course,
idea what they're doing, right? Everyone
Everything
who's gone to college and got civil engineering degrees and all kinds of other engineering degrees and have gotten a job in geodetic surveying is just like made up. They're all just
that's a straw
fake,
man.
right?
Not only
They're
that,
duped.
not only that.
now
they-
you're
wait,
taking
hold on.
you're taking in
Not
many
only-
things.
No, hold
You're
on.
taking together. You're talking about the space and the
Some random
engineering and
schizo on some random
you're
schizo
wrong
on
there.
Discord
You
discounts a civil
talk
engineer
about
with a
all this in the same place.
Not
It
only
is-
do they have to be lying, then the people that create the tools that they use, they have to be lying as well.
everyone's lying. Everyone's out
Yeah.
to get them all the time.
That's why I use 50-year-old, 70-year-old analog instruments. And I just put up a graphic of those 20-some measurements over, and you look at the scale across the bottom is miles. And yeah, the tower is, 1,000, 1,600 feet higher. And from every observing point, that tower, would be reported lower and lower and lower unless curvature and refraction, then it remains near constant. And that
It's
consistency.
like a NASA selling cream to overall the ladies in the late years, and say, "Oh, you have to buy this cream to get younger." So it's a fucking lie.
Well, that's a
There's
great
no
analogy.
There's no-
You've sold me. I'm convinced.
It's no cream that you can get you younger.
Is that no name I hear?
So I'm just telling you, it's a scam.
No, I'm in my sock.
It's a scam.
Yeah, you're
Yeah,
right. It's a
it
scam.
is.
It's not no name.
Nah,
Oh.
NASA is a scam.
No, I
Of
think
course
no
it
name
is.
is a scam.
Well, we're not talking about NASA right now. We're talking about surveying. So let's stay on
Yeah,
topic.
but surveying, I know about surveying. Surveying is just if you have a metric stick and you have some scopic view to the stick. That is it, and you have a metric to it. That's it. But
You know
it cannot.
about
That cannot work. That cannot work over long distance.
All right, hold on.
And you are trying to say
John,
it has
you
something.
know about as much about surveying as I know about open heart surgery, right?
I don't know, but I have working with surveys, so I know something.
Okay, someone had a question. What would happen if I ignore curvature and refraction? Well, let me just show you what happens when I apply curvature and refraction uniformly. And the graphic I just put up there is the errors from all the different distances, 10 miles, 100,000 feet, 120,000 feet, 140,000 feet away with a tower, 1,000 feet higher.
Bro, you're fucking posting a picture that literally spells elevation wrong. Like, what are you even posting? Like, it says elevation. Like, what the fuck are you guys even on
What
about?
the fuck are you talking about?
Honestly, arguing with you right now would be basically a form of, like, retard abuse, like, special ed abuse. It would be like abusing a freaking, like, toddler with, like, mental disabilities. So
I would say,
we'll hold him back if he does too much damage on you.
Have you ever
saying that is the same thing.
Have
So
you
that's
ever
also
have you ever made a
Okay,
spelling
but
error?
listen.
So, I mean,
listen.
if that's your root cause,
Regardless
though.
if the word elevation
Relax.
is spelled incorrectly.
The picture you put, error in tower elevation. Like, what do you even post? What is this picture even posted? What is it even? Like, it's just like some schizo There's some schizo ravings on Excel. Like, dude, yeah, okay, you're right. You got us.
What kind of expert couldn't spell elevation?
You got us with this little picture, dude.
Thank you.
The Earth is flat now. Good
It's
job.
a wrong word. You cannot use elevation in typical manner.
Okay,
let's have somebody.
Let's have a
explain
show
the
of
graph.
hands.
I want to hear
Whoever
somebody.
made
explain the graph.
Oh my God!
Hey, somebody explain that graph to me. That'd be interesting. Who made this Excel spreadsheet? And what does it mean?
Schizo.
Larry, go ahead.
Somebody asked what happens if you ignore curvature and refraction, and I showed the graph above, which shows an arc and the formula of curvature and refraction. And when I apply that curvature and refraction, I get plus or minus a couple of feet across the entire range. And that's from 1 mile all the way out there to 20 plus miles. And yeah, I had a spelling error. Like y'all all are innocent of that crime.
I'm just saying that, you know, if you had if you had actually gone to a university, gone through engineering courses, all this stuff, you would at least know how to spell elevation.
I
But
do
you
know
haven't.
how to spell.
You're just some
I do
schizo
know
on
how
the
to
internet
spell
ranting and
down.
raving about how the government wants to lie to you about everything.
I do. Okay. Have you ever misspelled a word that you ever misspelled a
not
word that you know how
elevation.
to spell?
I'm with you there.
Not elevation.
you
I've
ever
also taken.
misspelled a
Yeah, you
word
were in a hurry.
you
You
know
just
how to
slapped this
spell?
shit together.
I've never
should've
misspelled the
took your
word
time.
elevation.
Never misspelled a word.
Well, come on, why don't
Okay,
you tell
there
Not
you
the word
go.
elevation.
Larry,
But you don't understand. He's right.
Larry, why don't you
He's
tell us
just
what you
saying wrong words.
Larry, why don't you tell us
from the point.
Larry, why don't you tell us what this graph means to you?
There you go.
It means that the elevations, as determined at the instrument, the vertical angles measured from the instrument, and the
Wait a minute,
distances
vertical
from the
angles or
instrument.
elevations? Which one? Well, hold on. Let's get the terms down first. Tell me what it means to you, and be descriptive if you can.
That is the error in the measurement, plus or
What
minus a
measurement?
couple of feet of the distant tower that is 2,351 feet above sea level, which is about 1,600 feet above the valley floor from which those measurements were made.
Bro, he's right. I can't even talk to you. You couldn't even spell elevation.
Okay. It's getting a bit tired. I will talk with my friend Blue, Big Blue, and we will talk about the Coriolis.
Whatever you say, just be.
I know
Hold on.
Big Blue will never come out and talk to me about big
Let's stick to 25 miles.
Coriolis.
Can we take the
Yeah,
25
John,
miles
we're in the
to
middle of something.
They are changing. They are changing the object.
Come on.
We are changing.
Come
We are
on,
changing.
Johnny, please. Johnny,
We are talking about the Coriolis now.
Johnny,
So,
have a conversation.
yes,
with us real quick.
we are
So
changing the object.
let's take your number at 20 miles. The 20 miles, and you have a 1.7.
No, I want to
Johnny,
talk
I'm not
to
talking
Blue,
to
Big
you.
Blue.
Johnny, I'm not talking
You're going to
to
get
you.
muted.
Larry, I had a quick question. What it meant to him. Now I have a follow-up question. He has a value there. You can use one arbitrary point at a certain distance so we can kind of talk about it. At 20 miles, Larry, you said it's a negative 1.7, what is that, degrees?
Feet.
1.7 feet variation at 20 miles.
Yeah.
How did you discern that 1.7 foot at 20 miles?
Because I also measured it from 1 mile away. And at
Okay,
1
so
mile away, the error is going to be insignificant. Curvature refraction ignored. And
Well,
from
you're
20
saying
miles
what you
away, I
measured.
get the
So you think that you've measured something at 20 miles with a theodolite, and based on a flat surface, you only see a 1.7 foot deviation.
No, quite the opposite. At 20 miles, applying hundreds of feet of curvature and tens of feet of refraction, I get a constant elevation plus or minus those couple of feet from 100,000 feet away and 1,600 feet higher. I'm within a foot or two, which is like it's like the width of the crosshair of the instrument. And those are on multiple days across multiple months. So refraction is not whipping around like
I can show you pictures. I can show you pictures right now. And I was just there yesterday at 20 miles, like Catalina off coast of Southern California, where you don't see 400 foot of this mountain that you should see if it's flat. So is that what you're saying? You're going to see only a 1 foot variation?
That's why I'm measuring across
can you tell me
mountain ridges and a valley. I don't
Okay.
care.
So give me the data for that 20 mile point. Let's walk through that real quick. How tall is the mountain?
That's the radio tower, 2,351 feet.
2,000. I'm writing this down so I got it right. 2,351 feet.
And a half, yeah.
Okay, I don't need a half. That's the height of the mountain, and the distance to it is 20 miles. Is the distance 20 miles?
20.8599 miles.
So that's 5280. That's 105,600 feet, right? 105,600 feet. Would you agree?
Yeah, well, that's miles, yeah.
Okay. So now, at this point, we can tell the angle, and you should have seen that in your theodolite, how much is above level, right? Or below level.
All right, give me a minute. I'm going to open a computer, and we can go through this because this is exactly.
Because I don't see. I want to understand what you're talking
go
about.
ahead. Open your computer.
So
What are you gonna? Are you gonna do some computer maintenance? What are you gonna open on it?
And how high is the observer?
Nah, quit being an idiot.
Open computer, Larry. How high is the observer here?
Hold on, wait, guys.
He's gonna open my.
Hold on, wait, guys.
Hold
on, wait, guys. I'm gonna do
my computer.
Can you tell me how high the observer is?
Hold on, let me type in some
Can you tell me how high
calculations
the
real quick.
observer is?
Hold on, I'm typing in calculations. Hold on, wait. Oh, okay. Here it says the elevation of the.
Is that what we're doing here?
You sound like the.
Sound like he's being a dick, man.
Yeah, being a dick.
You sound like the ticket agent when he's like looking for their seats available on the plane.
Says here the elevation doesn't exist.
Yeah.
I don't know. This is what my computer is saying.
Computer does not compute.
Computer.
Did he ever say how high the elevation of the observer was? Let's just say it's
so high.
6 feet.
He was so high.
The observer, the
Was
instrument,
so high.
was at 742.42 feet
Okay.
above sea level.
Okay. So, what would the angular size of that mountain be in your field of view?
The angular size is
Irrelevant.
undefined because it's a point on top of a radio tower.
But you should be able to see that entire mountain top to bottom.
Yeah,
right?
but I was only measuring a unique point at the top.
And you want to know, and you're telling me by your measurements that from your 742-foot perch, that position using a theodolite measures out to be how high?
Sorry for interrupt. I'm
No, hold on,
waiting for
John.
a
John,
blue.
Wait,
hold on.
calculating.
No,
calculating.
no, I'm going.
Wait a
I'm
minute,
going out to
calculating.
smoke. I just want to say, Blue have to talk with me after you have talked. Then we have
Well,
to
we had
talk about the
DMs.
Coriolis. Then, okay, keep on talking
We
about
can
it.
talk
It's
for
just
us
about.
later. Just a sec. Oh,
Okay.
Go smoke.
so the angular position of that mountain, the top of the mountain, if that top of the mountain is with the top of the antenna is 2,351 feet, what angle would it be from the observer if you're at 742 feet?
I measured an angle of 0.70997 degrees.
Okay, so about 0.7997 degrees.
70997.
70997. Now,
The point
If you-
70997.
now is that where it should be on a flat Earth?
No,
If you're-
No,
if the
that's
surface
just
is
where I
flat?
measured it. No, that's just where I measured it. That's the instrument output.
oh,
On
from the
your
observed
theodolite.
location.
And it was down, below, or up above your viewing point.
That was a plus of 0.70997 degrees.
so in your field of
because
view-
I'm at 745 feet elevation,
All right.
looking up at the tower.
Okay, so 20 miles away, you have a little over, close to 3/4 of a degree inclination to that radio tower. Now, where does the flat Earth calculate? Where does the Earth curve calculator put that position to be?
This is boring.
We're just gonna call him out on some math here to see what this graph.
But I
even
think
means.
he's getting somewhere. Yeah, I think he's getting somewhere with him.
Yeah. Is that so? Tell me where it should be if the Earth is round. Where would we expect it to see it? To see that 2,351 foot object in our field of view with respect to level. Anybody know?
I'm sitting here not knowing.
Okay. Well, one way
Haven't
we
done
can
any
start
calculations.
this. What's that?
It's me. I haven't done any. I'm just sitting here listening. I haven't done any calculations.
Okay. So you're saying that the error of the theodolite based on what? Error compared to what? With respect to what?
Respect to all of the points in aggregate.
What do you mean all the points in aggregate? What does that mean?
That means I took all the measurements, not just one. I took all the measurements
Well, yeah, we could
and
plot
did the
that- we could plot
statistical
that-
analysis and mathematics to determine the refraction based on all of the measurements at significant distance, not
can
just
you-
one off and
How
not
can
one
you
and done.
determine the refraction based on this? How do you
Because we know the
determine
radius of
refraction?
the Earth.
You have an error that is all over the map here from different distances from the same observation point.
Wait a minute. What do you
Same
mean all over
elevation.
the map? What's the biggest number on there? 2.5 feet?
You have 2.5 feet, and you also have negative 0.5 feet at
Yeah,
a farther
okay.
distance.
Yeah, okay. Yeah, that is statistically a very small discrepancy. Yeah,
So
good.
where-
That's actually
again,
very
you're
good.
missing
That's
the
a gold,
point. What
that's a
are
gold
the
star.
what is this deviation with respect to?
Right, where are the
Where it
allowances?
should be on a flat Earth, where it should be on a round Earth. I mean, what are you showing here?
I'm showing you how consistent the curvature and refraction values that I came up with fit each other. And so that is a high level of agreement. Everybody wants repeatable science. So repeat it 20 times. And yeah, I get a couple of feet different.
So you
yeah,
got a
given.
regression analysis of these numbers, and it fits the data, it fits your expectation fairly well. That doesn't mean anything. That has nothing to do with what you're actually trying to find. It doesn't matter what the data is and how far it varies from a mean or an average.
Wait.
It matters what you're actually trying to measure.
I was trying to measure that variation. The whole point was to see those plus or minus of only a couple of feet with a 1,600 feet elevation change and 100,000 feet away. That was the whole point, to see that I can get it with, to see that my analog instrument and classic 100-year-old math can return plus or minus a couple feet at 100,000 feet away, because Lemon and so many others say theodolites don't work very well at those kinds of distances. Well, plus or minus 2 feet, yeah, that's the demonstration of it working very well.
Oh, so this could be the value of the curved surface, but you're getting a value that actually meets that.
The curvature being known, the unknown was refraction. And refraction, I came up within 2% of the textbook.
Well, you're so high that there should be the refraction should be a very significant factor, and that's what to me, that's what looks like you've shown there, right?
The refraction was about 4 arc seconds per mile.
Yeah, that's why I didn't get involved.
Relatively insignificant, like you said, it's the width of the theodolites.
Yeah, but but when I get 20 some miles away, then those are hundreds of arc seconds of refraction. It's just 4 arc seconds per mile. That's why I went 15, 20, 24 miles to really get a refraction that is so much higher than instrument error, and curvature, which is 1,000 times bigger than instrument error. And we can see that the instrument error was within a couple of feet. That gets the gold star.
Well, yeah, it becomes insignificant as you get further and further away. Obviously, there's going to be a deviation, but you're seeing.
You notice how when I get further away, the error doesn't get larger either. There's no trend to the error. It's Gaussian random distribution.
Well, it does look like it gets larger as you get further away. You started out at 0.1, 0.2, and end up at 2.4. 1.5.
But not in a slope.
Plus or minus too. It's still about the mean. It's still.
Yeah, plus or minus. That is absolutely the definition of random error, which is the best. Because anything else would be systematic. And systematic error, that's a mistake.
Right.
And yeah, the first couple measurements, when I'm only 2 or 3 miles away, or 2 to 4 miles away, yeah, the error is very, very, very small because I'm only 2 miles away. You can ignore, even if I ignored curvature and refraction, that's still only a handful of inches. But when I get 20 miles away, then refraction becomes 80 feet, 50 feet, and curvature is 300 feet, 400 feet, and yet I'm still get a consensus of all the data of only a couple of feet with a 1,600 foot typical elevation gain from 100,000 feet away with an analog instrument. What other proof could you possibly want?
What we want, Larry, is a physical demonstration. What you're showing is not physical curvature. Yeah? It's all
right, okay, but you've already given your qualifications guy off the street with no instruments, no measurement, no experience. So you're
it's not about me, Larry. It's about what we've been told. Yeah.
Okay, and this is this is my reality. I measured it.
Yeah, but you were told the same thing. That the Earth was curving. Yeah.
I made a separate measurement of the radius of the Earth.
Larry, again, you're not getting the argument, okay? The horizon is not...
I'm not getting argument. All right.
You're not getting the argument now. The argument is...
I did my part. Everybody asked for, it's never been measured. Look, here's an example.
That's not a measurement, Larry.
Just like they did for the Mount Everest survey.
Larry, that's not a measurement. The physical curvature doesn't exist. You understand what that means? So beyond the
Easy,
horizon, the horizon's not
Look,
falling
can somebody
away.
else can somebody else address chemo? I'm exhausted with his bullshit.
Well,
Well,
Larry,
the
that's
thing
just
is
the reality of it
sorry,
all.
can I respond
Larry,
to Larry because he just asked the room, Kilo?
hold on a second,
Or
Dress.
do you need...
That's the reality of it
go on.
all. That's the reality of it all, Larry. I mean, you've had me, you've had Witsit, you've had Lemon. I'm sure Percent got involved. That's 4 of us, okay, looking at your measurements. Oh, I'm sure there's been a couple of others as well. Peace of Mind was also involved. I'm sure 1 or 2 more. So everyone that has looked at your work, Larry, has been telling you that the measurements are not of a physical nature, okay? They are all apparent. So that means it could be here, it could be there, it will fluctuate. You'll never have a physical... Oh, and Johnny, sorry. Johnny's also been telling you as well. So we've all been telling you today, Larry. How many times have you been told today...
You're asking him a question he doesn't want to
by
respond to questions
numerous
because he's exhausted.
You interrupted me, Dress. You just wait till I finish. So, Larry, I know it's difficult, okay? We brought in the big guns today. We've got Percent here. Brought in Johnny here. Okay? These guns here today have shot down any idea of physical curvature. See?
You can't use the word shot and percent in the same sentence without us jumping in and saying, "Hey, Percent, what was the name of your sniper rifle?" And
Yo,
what-
don't disrespect don't disrespect Percent. You want to get shot?
Larry, listen, Larry, you little pussy motherfucker.
You want to get shot?
He also said,
Disrespect Percent. You don't even do that.
he also said big guns, man.
Yeah, and then the big guns co-show, Percent, we've got David up in here, we've got Johnny up, and Johnny is an absolute legend here. He was able to shut down Larry's observations, and Larry's panicking here, Larry. Look, you need physical Earth curve. Earth must be curving physically, you see? And we've been telling you that every single observation that you've made today has been of an apparent nature. That means Witsit told you it fluctuates. Percent told you Johnny's told you it fluctuates. I've told you it fluctuates. We're all telling you.
You're a leakant, and you're straightforward. And you don't think so much. You just say what you're thinking, and everybody gets it. And you're just thinking, and you're saying in your mind, you are fucking true. So that
Johnny
everybody have to understand.
I was waiting to be unmuted, Johnny, so I could respond.
Johnny, we'll take Coriolis later. Just hold on a second. So, chemo.
Chemo is true.
Can I at least make my point?
Oh, yeah, sorry.
That's okay. I'm not annoyed at you. One, chemo, you want to listen to the people that are talking to you when they don't want to respond to questions, and they tell you that, then it's kind of nice to make note. That's all I was trying to point out before you muted me. Just trying to help you. Stupid of me, I know. Secondly, yes, it is about you. It's about your criteria of evidence. Now, you keep using the word physical measurement, and I'm sorry, if we can build and engineer large buildings and structures to incredible degrees of accuracy, then we understand the tolerance of...
You're not talking about technology.
Johnny, come on. John, come on.
We are not talking about technology. We are talking about natural science.
Johnny, come on. John.
Come on, yes. Come on.
Johnny. So Larry went through this effort, chemo.
Yeah.
Chemo, you still there?
Yeah, of course.
Okay. So chemo, Larry went through,
okay, take it easy then.
I'm in the middle of a sentence, Johnny. Fuck. So Larry went through this effort and measured these objects at multiple distances, all the way to 24 miles, right? And he got the variance of where I was trying to get him to tell us what it was with respect to, and he didn't quite take the bait on that, but it's okay. The bottom line is he made these measurements. So either believe that he's lying or is unable to make those measurements with a theodolite. Yeah. He actually referenced things to like being the variation of the line in the theodolite itself. Yeah. And he measured these values angularly at distances up to 24 miles. Do you think those measurements were taken incorrectly? Because if they weren't...
No, we're not saying that.
Well, then what are you saying?
What we're saying is any measurements he makes are going to be apparent. So they're not going to be the actual, physical, demonstrable, repeatable measurements. So it's not like he's going to get the same results.
He just did. He just did that. He showed that there's a variance. He showed there was a variance of, a very, very small fraction.
Well, that's what he said. Yeah, he tried to say, there's a
Well,
small...
he showed it. He showed that. He actually gave you the values, and he gave you a plot, and that data was very tight to that mean, that center line.
Right.
So and it's repeat. That means it's repeatable. There's a very small error. My point, I was trying to get him to tell us, is that what he was concluding, or what those values were with respect to, whether it's a flat surface and those values mathematically work out to that, or was it a curved surface? And you'll see that works out to a curved surface.
No, I hear what you're saying, but physically, in the real world...
What do you mean it does? Well, hold on. What do you mean it doesn't?
It doesn't, because every single measurement he did is optical. It's subject to the environment.
Yes, exactly.
So you can't make any claims about it without refraction, as if it was a perfect vacuum.
But refraction doesn't work that way. It works. It's bending the light downward, so it means it looms it up. It can't work the other way, especially at 750 feet.
Yeah,
it doesn't work that way. There's never been ever witnessed.
It's not necessarily downward. It's towards the more dense area.
It always is downward.
It's not always downward, or else you wouldn't have superior mirages.
The atmosphere is always denser as you go down. The only reason you are so
not
caught
always.
up, flat earthers,
depends on local temperature and pressure. That's why you have superior mirages. If it was always downward, you would only ever have inferior mirages.
No, you don't. The only time you ever see this possibility of a different type of refraction is near bodies of water, where there can be large differences of temperature, and there can be small variations in density gradients, very, very in a very, very narrow band. We're talking about 750 feet above sea level. We're talking about 2,000 feet above sea level, and the area in between it. There's no way ever recorded that the density gradient has ever gone upward. It doesn't happen. It doesn't
matter, because even
it does matter. It doesn't matter.
It doesn't, because even his measurements, they're like line of sight. He's assuming straight lines. You can't just discount refraction completely.
We're not discounting. We're telling you that if there was refraction, it would bend it downward. So if we're seeing hundreds of feet,
would it bend the line that he's looking at it with downward as well?
Oh my God! Are you seriously, percentage?
No,
Can you
seriously.
think this thing through, please?
He's looking. There's light that's entering the lens of the theodolite, right?
The light
is that bending downwards as well?
What are you talking about?
I don't understand why people
Johnny,
please.
Johnny. The light comes.
We
from
have to talk about it.
4 miles away.
And anyways, yes,
and it will bend.
I will wait.
The light will bend downward. It'll be an arc. It has to be a curved arc. You get
doesn't
that?
Have to be. It depends on.
No, it does, because you
depends on
always
local
have
temperature and pressure in between the object and the
density gradient downward. Always, because the density of our air is always greater downward. You can't find, once you find some situation anywhere in the world that anyone's witnessed that the density gradient is inverted. Go ahead, and then we'll talk about it.
What do you think? How do you think we
but
have
the density is also awful.
Mirages? Use your brain. Tell me how you can possibly have inferior and superior mirages if they only ever go one way.
We're talking about at great distances of 20 to 30 miles. We're not talking about looking across water over 5 or 6 miles.
So you're saying it's impossible to have a superior mirage over 5 miles is the random cutoff that you...
Yeah, you cannot have a superior mirage 1,000 foot above the surface. No, you can't.
Where's your data supporting that 5 miles is the cutoff?
Because I know how superior mirages are created.
So you just made that up like
no,
arbitrary
because
number.
They have to have a... Oh my God, percentage. Do you even listen to yourself?
It is an arbitrary number.
Not an arbitrary number.
Yes, it is.
Superior mirages are superior and inferior mirages are taken near the surface of the surface, within 10 or 15 feet.
That's the point.
Not seeing mirages. You don't see mirages when you're 1,000 feet above the surface. Certainly not thousands, multiple thousands of feet, because the density gradients are consistently down. And now, if you can find an area, find one measurement that someone's ever measured where there's a density gradient that's been inverted, please bring it to the table. But you won't.
So you're saying it's impossible to have a superior mirage with an observer height of how much feet?
Any significant distance above the surface.
What's that in numbers?
1,000 feet. Just
So
close to
it's
1,000
possible
feet,
to
let's say
have
1,000
an
feet.
observer height with a superior mirage with an elevation of 1,000 feet.
Right.
Is that what you're saying?
Yes.
All right. We'll see about that.
Go ahead, you can find it. You won't. Now, I know what you're going to do. You're going to go find some person looking on a hill or a mountain, 1,000 foot, and looking at some superior mirage over the ocean. Remember, all the objects have to be over 1,000 feet above the surface.
Shifting
Therefore,
the
you will
goalposts
not have
already.
this.
I haven't even started looking.
Whatever. I'm just telling you, having your brain look. You're not going to get any superior mirages when you're 1,000 feet over a surface.
Okay, so Larry, are you starting to dig the point now? Is that because there are no practical physical measurements, it's all based on apparent and assumptions and wiggling and finding a general number, you see? And that's part of the problem. Without that physical, practical measurement, you're assuming everything. I mean, like Witsit already said, and I already told you previously, you're assuming a planet, you're assuming gravity. How on earth do you expect to get correct results when your starting point is an assumption? That's right, Larry. Think about these things, right? You've been lied to. Now that you're trying to correct this information and say, hey, we haven't been lied to, but you can only show apparently, not practically and physically, that the Earth is actually curving as you say it is, Larry. Now again, you've been told 4, 5, 6 times, 7 times today, and still finding it hard to grasp.
Yes, Larry. Tell us, Larry. What's going on, Larry? Why are you not speaking? Larry, are you shy? Are you wrong? What's wrong with you?
Now David wants to tell you about your apparent measurements, Larry, you see? Now, of course, Larry, if you rub shoulders with ball earthers, they'll give you, yes, 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 of course, Larry, yes, it just perfectly fits with the model, yes, yes, yes. But that's not going to help you find the truth, right? You're going to be stuck in this fantasy land. Now, whereas we've told you, go out there and make physical, real-world measurements, and then show those, and then obviously it's curving, right?
Really? Isn't that what he's already done?
No, all he's done is go by the assumption there's a planet, the assumption there is gravity, and various other assumptions. How can he expect to make measurements based off assumption?
Okay, well, so present your measurements. That way we can compare.
Well, we can only go by what the experts have told us, and obviously go out there and try and test it.
Lemon, I want to go by what you've done. Let's use yours.
Lemon is not here at the moment, but I'm sure when Lemon
I'm sorry, not Lemon. I'm sorry, you.
Who?
Chemo.
Who? Oh, Chemo, me, yes. Okay, what about me?
Yeah.
What about Larry?
Let's use your measurements and we'll compare it.
What about Larry?
Your measurements to Larry's and we'll see.
No, Larry doesn't have any measurements.
Yeah, he does actually.
No, I call this the Larry effect.
Right.
When people believe Larry,
We're clicking, Zanuck.
I call it hilarious.
Does anybody else have any measurements to present?
No, because look, B-Ball for life. Try to understand. All of us were told.
I'm trying to understand.
Okay,
I want to see your measurements to compare to Larry's.
Okay, so we were told what Larry is telling us, that the Earth is aboard 3959. What we said to Larry is, the horizon's not physical, so therefore you can't have a radius because there's no physical
Yeah,
drop.
Larry doesn't use the horizon to measure anything. He doesn't use
That's
the
the
horizon.
point. Because he didn't, he doesn't know if the Earth actually
He
drops.
uses reciprocal zenith angles. That's what he
Yes,
uses to measure.
but the Earth actually
So
physically.
let's leave the horizon out of this. We don't need the horizon.
Well, I'm saying from the horizon. From the horizon, the Earth physically curves, right? Yes, no?
Yeah, but we're not using. He doesn't use the horizon to make his measurement.
No, but that's what we use to verify your 3959.
Well,
Do you understand?
Okay.
So we're going to test the globe.
So let's
stop the
see your
clicking.
measurements then.
Okay, so we have the black
'Cause I don't
swan,
remember
right?
Timo, stop saying that.
remember
It's
ever
not
seeing
me,
your
all
measurements.
right? Somebody else.
No, it's you.
It's not me. I'm muted.
Because I don't,
muted.
Chemo, I don't ever remember seeing any of your measurements pair.
Okay, again, let me explain.
You keep saying the black. We have the black swan. We have this. We have measurements. But like, let's see those measurements. Because
Okay.
right now, all I've seen is Larry's measurements.
Okay, so do you understand the black swan argument?
Yeah, we understand the black swan argument. Please do not repeat it.
But this proves that Larry is either lying or mistaken, doesn't realize what's going on.
No.
Yeah?
Again, I'd like to see your measurements, Chemo.
Okay, so I use the
Seems
black
like you haven't
swan
made any.
as my measurement. Black swan has been measured at the platforms. We know how far they are. We know the height of the observer, and we know where the geometric horizon should be. See? So we're saying to Larry, Larry is telling us what we were all told, that the Earth is a ball, 3959, blah blah blah.
Chemo, did you take those pictures of the black swan?
So
No. Okay. Did you make those measurements of the black swan?
no.
Okay. So where are your pictures and your measurements?
I'm using the black swan.
You can't because that's not yours. So how can we
you
verify
can.
that that's an
It doesn't have
real
to be
picture?
mine. There's a fallacy for
That's
this
some
that you're
weak-
doing now,
weak
making me get it
gatekeeping.
right now.
You know, you guys like to say, it's testable, repeatable. So how come you haven't repeated this measurement?
Because it's been done.
Oh.
Black Swan has been repeated like 3 times.
So Larry's gone out. He's made measurements multiple times. And where are your measurements to compare to those measurements? Besides using someone else's photo and someone else's numbers that you think are correct.
What's wrong with using the same thing as before? Repeating that measurement.
Because he hasn't repeated it himself.
The Black Swan has been repeated multiple times, bro.
Yeah, and every time we see the black swan, there's a different type of picture. It looks different.
Exactly, so it's been repeated. So what's your
Exactly, yeah.
point?
It's supposed to be different. It's not supposed to be the same, is it?
Have you gone out there? Have you taken any measurements?
What does it matter if I've done it? It's been done.
Chemo.
Yes.
The YouTube stream isn't scrolling on YouTube.
Oh my god.
If you could tell Jem that, or
What do you
get
mean
something
it
done about
is? What do you mean it's not? What's not streaming? I see it streaming fine.
Yeah, but there's no. You put in text and it doesn't come up.
Oh.
Just let Jem know or whatever, please. Okay, Chemo.
Yeah, no worries. Thank you.
Okay, bye bye.
Bye bye.
Peace, man.
So how many different photos of the black swan are there?
Talking to me, you're talking to percent.
More than one.
Who you talking to?
Oh, I'm talking to you, Chemo. How many pictures of the black swan are there?
Well, there's every horizon is a black swan.
No, I'm asking a specific question. How many?
I
pictures
haven't I haven't taken the observations. I've already told you that.
Okay.
He's asking the Pacific question. The Pacific, the Black Swan off the coast of Cali.
Specific.
There is no specific black swan.
Specific. The one that you guys like to point out. Oh,
There
look.
is
the
no
horizon
specific
is
black
farther
swan.
than
What
it
we
should be.
understood from the black
That's the one.
swan is that every horizon is not physical. Not one. Anywhere ever.
Really?
Mm.
Yes.
That's
Okay,
the
so-
argument. That's the point of the black swan. Is every
So
horizon.
in
What?
that picture, what else is going on? What else is going on in that picture other than you seeing the horizon farther? What else is going on
You want to say
in
refraction?
the atmosphere?
You want to say refraction?
What's going on in the atmosphere?
You want to say refraction?
That might be one thing.
Okay.
Since it changes so much, why would we even use that as a baseline?
Yeah, but you understand the Earth is not physically dropping away anywhere from any horizon, anywhere in the world.
That's a claim. That's a claim, right?
B-ball, you understand the horizon is purely an apparent thing, right?
Hold on, you might be able to convince me with this black swan argument.
It's an apparent phenomenon.
What? But
Like
my
if
only question
your eyes
is,
were closed, you realize you wouldn't see it wouldn't have a horizon, right?
why are the oil platforms at two different heights?
Because they are being
Perspective, bro.
obstructed by a non-physical obstruction, as it were. I'll send you the picture here.
No,
right now.
but that's a good.
They're
That's
different
actually a really
heights 'cause
good
they're
question.
different distances.
Because they're supposed to be this. They're on the same level water, right?
Yeah, they're on the
So
same
why
level.
are they at different heights?
They're at different heights, though.
That's a good question.
Are you guys trying
Water
to argue
is
that
always level, right?
angular size
Is one
change
shorter
over
than the
distance
other?
shouldn't exist now?
No, it's not angular size. It's angular position.
I'm just confused
Why
as
is the
why
angular
the one
position?
is why the one in the one that's more distant is like at a lower height than the other one. I mean, it just doesn't make any sense to me
Because
because
the angular
water's
size
level,
of
right?
things
No,
gets
no, it's not
smaller
angular
as they get
size
farther.
percentage. It's the position. Listen to Larry.
No, he said the height.
No, he said angular position. It's lower.
No, he said height, bro. He said
Yes, the
why it's
height.
smaller.
The height of it with respect to the closer one is lower. Why is it lower?
Because it's farther.
No, it doesn't make it go lower when it's further. Things
Yeah,
at the same height.
angular
No.
size
Okay, look.
change makes
Picture
it smaller.
you're a guy. Picture you're by that bottom bar of the first platform, the closer 4 mile platform, and you're 6 feet tall, and you're 7 feet off the water. Okay, you're right on the water there. Look at the other platform. That same, and you're looking at this person from a 6 foot observation point on the shore. The 6 foot person on the furthest platform, 10 miles away, should be exactly in line. You, the first platform, and the second platform, all with people on that bottom bar, all should be directly in line. Yes, your angular size will get
That's
smaller.
all he was asking.
Hold on,
bro.
but
You're
hold
on-
on.
you're
Your
talking
angular,
about
hold
something
on, hold on. Your angular size will get smaller, but the position in your field of view will not change a bit. Yet, what he's telling you is that it's going down. It's lowering. That's not what happens with perspective.
That's not what he was asking about.
Yes, it was.
No, he was asking about
Exactly what it
the
was.
height of
Why is it lower?
one of the towers relative to the other tower.
Yes, why is it lower and why is the bottom missing?
He wasn't talking about the lower than
No,
the observer
he-
or what
look,
have you.
Let him speak then. You're wrong. He was saying it's lower and everything.
Go ahead,
is
bro.
closer to
Ask the
water.
guy what his question was. He was asking why it was shorter than the other one.
Yes, it's not because it's further away.
Lord have mercy.
It's the angular position has changed.
Danny,
The center
let
line.
Hentel Hamster answer. or
Danny's
make his-
right. The top of the mountain, right? Isn't it further away than the bottom?
Hentel, he's still here.
Yeah, I'm still here. What's up?
We're asking about the black swan or something.
Yeah. Why are they at different heights? I mean, water always finds its level, so everything in the ocean should be at the same level if they're the same height, right?
Yeah, but are you looking at physical water? Is that a physical obstruction?
What do you mean physical obstruction? The water's not obstructing anything. You can clearly see that the
water not-
platforms are at two different levels, but they're like the water's level,
Water's
so I
not
don't know.
physical anymore.
The Earth is flat.
The physical water is blocking the physical.
Has the
oil
center line
platform.
changed?
Do
Has
I
the
just
center
have?
line- has
Do
the
I have
center
to
line of
change
those
the
two-
medium?
Has the center line of those two observations, those platforms, has the center line of those two changed with respect to one another? If the answer is yes, you have to ask yourself why. Why did the center line of the further platform go down? That's what he's saying. It's lower in your field of view.
Yeah. And then a different one, it's higher. I mean, like, I don't know. Like, what explains for this?
Well, how do you explain it? Are they sinking? Are they rising? What's going on?
I mean, it must be some sort of atmospheric distortion, maybe, right? Maybe there's like some sort of medium in which is making them change. Just like how for gravity, you have to change the medium to, you know, I mean, not gravity, but, you know, the density, you have to change the medium, just how you guys say with water, right? To
I know, but we're trying to
observe.
figure out if the obstruction is physical. And if it is, why is that physical obstruction now behind the physical platform?
Physical obstruction behind which platform?
Did you see the image I posted? I'll post it again.
Image of Whale Crusher 1, right? Yeah, I'm looking at it.
I'll post it again. So on the left,
Yeah.
can't see the legs.
Yeah.
And then on the right, you can see the legs.
I see what you're saying there. I mean, like, what are you trying to say that
Well, I'm asking
like,
the Globers, is that physical obstruction? They say yes, that's the physical earth in front of the platform.
Yeah, well, so the one on the left is physical obstruction of water, right? Because maybe the atmosphere is a different consistency that day, so it makes refraction different. And then the one on the right, the atmospheric conditions are right for refraction to make it look like you can see it further in the distance.
Yeah, but
right?
You
where's
contradicted
the...
yourself, bro.
If you understand,
You said it's a physical obstruction on the left, and then you cited refraction, which would be an optical effect.
Yeah.
Not the physical water blocking it.
Because all those things are different on every day. It's not all the same every single day, right? It changes
Hold up, are you
based
saying
off the weather.
that the water, it's like a difference in tide or something? That in the left, it's reaching the, you know, the top.
It also
of,
could
like,
be
the
tides,
legs,
yes, it could
and
be
then the
tides.
bottom, you can see the legs of the far tower. Far
so
rig.
that's the observation you usually see. 99% of the time you see that percentage. And you look at the proportions of the actual platform in the distance. Notice how it gets narrowed. Hold on, it gets. Let me
Zanuck,
finish.
hold on a second, because we're just trying to get through with Hentel
It
here.
gets
I was
narrowed.
waiting for an answer for
Yeah. So the one on the left, right, and the one on the right, both of the front platforms are the same exact size, right? Like
Sure,
the
more or
water
less,
isn't the water isn't higher or lower, so I wouldn't say that it's tides. I would say that the one on the left has the atmospheric conditions where you can see more so what is the accurate depiction of what's going on, which is the further away platform is behind the curvature of the Earth. Whereas on the right, you have refraction, which is making it appear further up. Because
So
you
it's
have
not physical obstruction on the left then, it's just...
No, it is physical obstruction on the left, and it's not on the right. Because on the right, you would have physical obstruction, like on the left, if it wasn't for the atmospheric conditions. Because you've even seen ships look upside down in certain atmospheric conditions in the distance.
Okay, that's an optical thing again.
Exactly, that's why on the right it's optical
water
because of
isn't
the
actually
atmospheric
reaching
conditions.
the
Did
bottom of
anything
the thing,
change?
right?
Wait. Did anything change between the left and the right? Look at the right one. Is there a change of that platform on the right versus the platform shape on the left? And the answer is yes. It's gotten narrower and also is loomed up because that's what happens when it's loomed.
Exactly.
It's moved up and it's gotten narrower. So that shows there's an optical effect there. There's no optical effect in the left one because those platforms are the proportions they should be. In fact, if you looked up those dimensions, you would see the ratios are all in sync. If you looked up the ratios or use those ratios for the right picture, those ratios don't work on those pictures, showing that there is distortion. That's why it's loomed up and stretched taller.
All right, I see.
So
we've
explained.
Now look at the left one. I see your, optical effect on the right one because it's, more narrow, what have you. But look at the left one. It's more light. It's more washed out. Why? Because there's more opacity in the atmosphere. How come the darkness of the one on the right is more apparent versus the one on the left? It's more like, watercolored.
I mean, the color doesn't really matter. It comes down to the
color is indicative of
I was
water
down
in the
there that
atmosphere.
week. There was smoke in the air. It was hot.
For
There was
us
a lot
to
of things
really
going on
know
atmospherically,
All
which
of
made me
things that
loom-
can cause
Why-
atmospheric effects.
Yes, and that's why you on the brown one, right? You have it loomed up because that's how looming works.
No, I'm talking about the one on the left.
There wasn't any. That's a normal day. That's what it always looks like there.
It looks like there's more sky in between. You understand?
More sky in between.
The color
you
of the
can't
dark
really
part,
tell that from
the
a picture. You
shaded
would have to
part of the
actually
rig
measure
is
the
more
air.
in tune with the color of the sky.
You
It's
would have
like
to
there's more
measure
air
the
in
atmospheric conditions on
matter.
that day.
Well,
You'd have
more
to measure
sky in
it.
between what?
Pictures don't really
Of the
say
observer
anything.
and the rig.
What do you mean? There's more sky in
Look at the
between?
color of the rig from the left to the right.
It's the wait. Hold on. I know what he's talking. He's talking about the medium. There's a medium in between them, right? You have to change your perspective
if
on
it's
the
more
medium.
washed out, that means that there's more matter, more density in between.
Yeah.
which would
Density,
be
yeah, exactly.
more
Density.
density means more,
More
refraction. So
density?
you could argue that there's more refraction on the left
No,
one.
more dense refraction has no.
Density
There's
in the
gonna be a
medium
differential- no,
equals
there's
more
gonna be a
refraction. Are
no,
you trying
because
to deny
air-
that now?
no, air-
And that's also, isn't that also why the one on the right, it's levitating, is because there's more, wait, hold on, wait, there's
It's
more
not levitating.
density.
That's how it's supposed to look.
It's
Wait,
not
so the one
about
on the
density,
left,
The legs are
it's about
supposed to peek
it's about
out just
the
like the
gradient. It's
front
about
or
the
the
gradient.
foreground.
oh, wait, hold on, I get it. So the one on the left, there's more density, and that's why it's lower, is because the more dense things are, the more under the level they are, right? Is that what you're saying?
I'm arguing that, yeah, you could say that there's more density because it's more washed out. There's more humidity in the atmosphere and stuff.
Why is it more washed out? It's not more washed out.
Look at the color, bro.
It's not more dense. That day is more dry and more clear. The
If it's
air-
more clear, then how come the color's like
blue,
more closer
That's
to
what
the
guys are
sky?
blue. Because it was a smoky, fire-filled.
It was clear but
region of
smoky
the
and
state
fire-filled?
that week, and it was warm. And you have a look at the ocean. Look at how calm it is there. There's no wind, and you
Look,
get
the
a
only
refractive-
way
you get a
for
refra-
both
hold
sides.
On, hold on. You get a refractive layer there because of the density gradient. That's why you see things loomed up. The light is bending more downward, looming things upward. That only happens when you have a distinct density gradient that goes down. They loom up. The other
Disagree.
picture, hold on, the other picture doesn't show that. The water's not very still. It's a little bit of chop to it, and it's blue skies. It's very clear. The temperatures are and the gradients are as they are normally, like 90% of the time down in that area of Santa Barbara.
If you say so. But okay, point number 2. Look at the tower. You have that line that's attaching to the tower, right? And the one on the left, you can't make it out as much. It's more distorted. The one on the right, you can. Why is that? If the one on the right has so much more atmospheric effect than the one on the left.
It's not a matter of so much more atmosphere. It's a matter of the
So it
gradient.
only doesn't matter if it's, if it helps your argument. You're
it's a-
cherry picking like a motherfucker.
No, I'm not. It doesn't have to do with that. It has to do with the fact that there's a gradient, not how much atmosphere you're looking through. The air, the gases are invisible. Gases are
Yeah, but
invisible.
opacity in the atmosphere is not.
Yeah, but now you're talking about like, if he's talking about smoke though, that's going to
There's
cause
smoke,
that's a
and
different
there's
effect. It's
higher
not going to be
temperatures,
the same as
and there's a
refraction.
higher gradient.
Smoke would cause
So
the washed out effect, but it wouldn't cause this this amount of refraction that you're talking about. It would be like Zanuck is saying, the gradient between the mediums, the density from the lower.
And you're saying
Grim, you're
think
really
that-
low, man.
Yeah, and you seem
sorry,
to
dude.
think that because this other, I will give you the fact that that's a denser day. I would say probably the pressure and the density of that air is probably slightly greater in the left picture. I'll give you that. But the point is, why is it loomed up on the right? And if it was a denser gradient, and you said that causes more refraction, then why isn't it loomed up even more? It's down. That doesn't work for how refraction works. The density gradient is always going to be down, especially on the denser day.
It does show a clear example of something in the distance being loomed up, though. Either way, I mean, it might not be perfect
Again,
evidence
missing
for
the
anything,
point
but
of
it
the
does
Yeah, it
show.
could be loomed up a little bit on the right and loomed down on the left. Who's to say what's actually
Why would it be loomed down?
happening?
You can't have loomed down. You
if I
can't
saw
loom
the
down when you have
distorted
a density gradient
if the-
downward again.
Zanuck, I'm
Not
here
how
too.
it works. Percentage,
I agree with
on
you.
You said
bringing
it's
this up.
more dense.
No,
Light
it doesn't
bends
matter.
down,
No.
the more dense it is. So
Yes, and that means-
you
that means
yourself
it'd be
would
loomed
agree
up
that it's
even more.
bending
That means-
downwards.
No, that means it'd be loomed up even more. The object
When
doesn't
light
Well,
move
then
bends
obviously
down,
you're,
it looms
you're
up.
double
The light
speaking now
moves-
because
the
you said it's
light
more
moves
dense and now you're
the
saying
light-
it's looming
listen, let me
down.
finish a
So you
sentence.
have a contradiction.
No,
He never,
contradiction
he
that
never
reconciles.
said it's looming down. He never said it's looming
I never
down.
said
No, you
it's
said it's
looming
more
down. I said
dense,
the
and he
light-
said it's
Only
not
you
looming
did.
down, it's looming up.
It
Right?
has
No,
to
the
always-
light's
but we
bending
see it-
down.
we see
Light
it
bends
downward.
down, and listen, you're confused. When light bends down, it looms an object up.
Correct.
I know, but in the image to
But
the
that's
left,
what he said.
it's down.
No, the light.
It's just where it's supposed to
It
be.
should make it
You don't
worse.
see any distortion in the object, do you? You don't see that
If-
it's distorted at all. So why would you think it's being
How do
loomed
you
at
know
all?
it's where exactly it's supposed to be, as opposed to
It's
being
an
loomed
it's a
down?
good
Because you can
signature
measure
of
it.
being loomed
You can
is
measure
when
it.
there's distortion in the object. Then you have
You can
like
measure
then
its
you can
angular
say
position based on your distance and its angular size and determine where it should be in your field of view.
Okay, show us in a perfect vacuum how it would look.
Pretty
We
close
can't
to what
do
you
that.
see there on the left.
Are you
Who's had a
presupposing the surface when you say
No,
it
you're
looks
just
like
measuring
how it
its
should be
angular
without
position. You
refraction?
just measure its angular position.
Yeah, we can't do that.
in the field of
Honestly,
view.
there's no perfect vacuums.
You don't
No, you
know
need to
if
have
the
it.
one on the left is where it should be or if it's looming, if it's down a little bit. You have no idea.
You keep on confusing downward refraction with looming. They're
I'm
two
not.
separate. Okay.
The more dense the medium,
what happens,
you have something looming
what
up
happens
because
when
the
an
light
object,
bends downward.
What happens with the
right?
object?
But that's not what we see in the
What
light.
happens what happens to the object when the light bends down?
What's that?
Listen. What happens to the object when the light bends down?
It's looming up. We see
Correct.
it
Correct.
higher.
You just said
So
that.
if you
Zen.
said that it's denser on the left, then it would loom. Why is
But
it
it's
below?
not looming. It's lower than the other tower.
So why is that?
So that's what I'm saying. You have to reconcile this contradiction.
Because
You
it got
admitted that
earth
it's more dense,
Because
and you're admitting that it's
It's earth
a little
curve,
bit
dude.
lower than it should be. So
I didn't
how do
say
you
that. No, I
how
didn't
do you
say that at
reconcile
all.
this?
It's exactly
If
where
it's
it
so
should
dense,
be.
it should be looming
see,
up. How
that's
come
the
it's not
point.
looming up,
If you
Zanuck?
measure it, you can measure that. You can measure that percentage. Just stop talking and listen.
Bro,
You
you're
can
not
me-
you're not
Stop
addressing
talking.
the
Just stop
contradiction.
talking for a second.
How are you
Listen for a
missing
second.
this?
Just listen. If you measure it and its angular position is where it should be for a curved earth and not where it should be for a flat surface, you then can discern that it is exactly where it should be, or near exactly where it should be. And if it's not looming up, because if it's looming up, it'd be higher, as in the right picture. You don't
Yeah, you
understand
can
how
try saying
refraction
that
works. You just don't
after
get
you
it.
address the
You
contradiction.
really don't get
the
it.
contradiction.
Seriously.
Hold up, Zanuck, real quick. The contradiction is you said the one on the left is you admitted it's more dense than the one on the right. There's more density there, right?
I said I gave you
Density
that.
bends light downwards. We should expect to see it being loomed up. We do not see it loomed up. Why do we not see it loomed up, Zanuck?
Because it's not about the density. It's about the density gradient and the angle of incidence. Don't you get
Okay,
it?
so refraction only matters when you
It's
want
the
it to
same
matter.
answer he's been telling
No,
you the whole
but
time.
refraction only happens when there's a density gradient and concurrently an angle of incidence. Without it, there's no refraction. Snell's law, basic 101 stuff here. You don't get it.
You
You've
haven't
never
addressed
gotten
that.
it. That's just the way you are, percentage. You're a Poe. I get it.
There's density there. You've admitted there's density there.
It's-
You admit that
you're
density
not
bends the light
listening.
downwards,
You're not
meaning we should
listening.
have
No,
looming. How
no.
come we don't have looming if
No,
there's density that bends,
there's always gonna be
bends the
some,
light downwards?
There's always going to be some looming if
Fermat's
there's a density
principle.
gradient and angle of incidence. And I would suspect there's some slight ability of looming to be in that picture to raise it up slightly. Now, how much? Very, very slight. How do we know that? We measure the angular position in our field of view.
You have
and we
no
see that
idea, do
we
you?
see. Stop it. We know exactly where it should be, and that's where it is. Now, what we do know is if the surface is flat, that's not where it is. It's much lower than it should be if the Earth was flat. So why is it below where it should be? Why is it below the first platform? Why is a 6-foot observer on that first platform and the second platform that person would be missing? Why is it lower? It should be directly in line.
Don't try to
That's
switch
the
it, bro.
question you
You're
gotta
the
ask
one that said
yourself.
it's more dense, and yet it's not
It
looming
doesn't
up.
matter if it's more dense
It does.
or not.
It does
It
matter.
doesn't.
You said
It doesn't.
density always
No.
bends light down.
No, I
Always.
didn't say that. You said that. I said the density gradient, and I'll say this is the fourth time I've said it, by the way. The density
It always
gradient
bends towards the
stop.
more
This is why
medium.
you're repeating the same error because you're talking over people.
So it's wrong for me to say that?
Stop,
That light
yes.
always bends towards the more dense
Because
medium?
no, density does not bend anything. That's not how Snell's law works.
Light always bends towards the more dense medium. It's wrong for
So
me to
now
say
you're
that?
invoking gradient. Good for you.
Wow.
We have to have gradient.
Listen
A
to
gradient, not more dense, a gradient. And the light in a gradient with an absolutely has to be present. An
More
angle
dense
of incidence.
compared to less
You're
dense.
talking
There's a
over me,
gradient
so you
therein.
can't be listening. You can't be listening. So the
No,
angle
you're
of
being
incidence
pedantic,
and the
bro.
density.
You're saying
You're doing it
it's
again. You're
more
doing it
dense
again.
No, he's not being pedantic. He's being very specific in the words that he's using, which you just want to generalize
If you
and
have
then
an
backpedal when
atmosphere,
you
if you
get
have a
said
medium
wrong.
going from less dense to more
Go
dense,
ahead
that's
and
a gradient.
keep doing it. Just talk over people while they're talking, because then the point can't get across, Pocon.
You have no point. You're pointless.
No, my point was to point out your fucking irony.
Fantastic. Good point.
Oh, it is a very good point there, Stolen Valor.
So, Zanuck, when you have a medium that goes from less dense to more dense, is that not a gradient?
That is a gradient.
All right. So what's wrong with me saying that light, you were saying that light always bends towards the more dense medium. How is that
Yes.
not
Yes, but
concerning a
then
gradient?
you basically took that to mean that because the picture on the left has and I gave you. I didn't say it was or wasn't. I gave it to you because it's not a big deal.
No, you admitted
I
that
said
it's more dense.
The air was probably denser that day. It doesn't mean there's a density gradient. Doesn't mean there's a density gradient is any different than the right or left. It means that there is more density in that air. The air pressure might be higher. Temperature might be lower.
So you're saying that it's just more dense there, but there's no more of a gradient.
No, why would the gradient be different? Why would the gradient be different?
Why would the gradient be different? Because there's more density lower down. So
No, that doesn't mean the gradient is any different.
Wow.
Seriously, you don't understand how
You're honestly trying to say that you're going to have light bending just as much, even though it's more dense in one of them?
Yes, because the angle of incidence
being
and the
dishonest
gradient
right now.
has to be different. The gradient on the right is greater. There's a density gradient that's different on the right, much different. Even though the density is higher on the left, the gradient is greater. There's more of a gradient. I don't know words to use that you can understand, but you're not getting it. On the right, there's a greater density gradient nearer to the surface.
Do you have refraction data from top and bottom?
No, because all we have
The
to do
local
is
temperature
measure
and pressure to be able to say that there's more
all
of a
we need
gradient?
to do is measure the position, the angular position in your field of view of the further object and see where it should be on a flat surface. And it's lower. On the right, it's above. We know light bends downward. So we know the right has to be looming.
You're affirming the consequence.
I'm not affirming the consequence. I'm
Yeah,
telling
you have this
that we can
idea
actually
in your
measure.
head, and
We
you're
can measure
disregarding
and
any
we can
evidence
measure-
that goes against what you're saying.
No, we can measure the position of those objects in our field of view. Would you not agree? We also have another piece of data here. We have the first object. Both those objects, in fact, in this picture, it shows it perfectly that they are at the same position angularly in your field of view. But yet the further object is lower. Now you're saying that one might be upward refraction, which made it lower, and that doesn't occur.
Wow.
We don't see upward refraction ever.
We never see it. Here we go again.
No.
Broken fucking record.
No, we don't see objects lower in our field of view due to upward refraction with water and air.
Hot mic, Johnny. You got my hot mic.
I'm just saying thank you to you. That's it.
Okay. Got a hot mic there, Vicky.
But I give you a lot of things. Okay, but we'll go on with things.
See, where it should be on a flat surface and it's not there, you have to say what's causing it to not be there. Obviously, it's optical. And how would something change optically if it's supposed to be someplace that it's not? Either there's curvature or there's some type of optical effect.
There's always an optical effect.
Correct.
But you have to understand
I don't
the
have to
reason
understand what you're
the
telling me.
photo
You're
on the
making
right
nonsense.
has brighter light colors and darker dark colors is because there's less opacity. There's more opacity in the one on the left because there's more matter, more water, whatever it is that's washing out the picture. Okay, there's more density there. So there's going to be more refraction.
No.
Yes.
That is not true.
Maybe I can say
more refraction.
Maybe I can say
the first black swan you guys discounted it because you said there's so much distortion. Look at how much the thing's bending and stuff. And now when there's more refraction, more density in this one, you guys are trying to use it as a proof.
That's not how
It's cherry
refraction works.
picking.
That's not how refraction
It's
works.
rules for thee, but not for me.
That's not. So you said it's a denser day. Well, let's follow along. Let's connect the dots here. So on the right, on the left, you said the air is denser. So we'll kind of assume that's probably a cooler day with the air being denser, so higher pressure, higher density, and the gradient is whatever it is. If we go to the right, we already said that it's less dense, so it's probably a warmer day. But the water temperature didn't change. So what would that do to the density gradient?
Double angled incidence, genius. On the
Hold on. What would
one
the
angle of incidence.
what would
Going straight
Don,
through
you're not
up or
helping.
below
Don,
your mid-level of
Don,
your
you're
eye
not
point. You
helping.
asked a question. I'm answering your fucking question. Shut up.
I wanted percentage to answer it. So we had this picture on the right where it's a warmer day. So what's the density gradient with respect to the water now, Don?
It doesn't matter what the water is. The water
because that's what's going to cause you the density gradient.
No,
That's
you
what's
look at the air above the water.
What causes the density gradient to change in that picture?
The density gradient changes depending on the local temperature and pressure.
Okay.
So you
if
look
the water
at the air
temperature
above.
So
if
you
it's a
would
colder
agree the
day,
water,
then it'll be more
you would
dense.
agree. Hold on. You would agree that does the water temperature affect the air above it in any way?
The temperature of the water? No.
Really? What?
No,
The temperature of the water as a body
material
won't.
would affect
It's about the water that
material.
Are you out
in
of
the
your
air.
fucking mind?
Shut the fuck up, dude.
Fuck off.
Shut up. The water doesn't
No.
matter. The water's going to warm up the
Really?
air, but
The
it's the temperature of the
water
air that
doesn't
all matters.
matter?
Stop. He's
Okay.
100% right.
Yeah, the
Stop
body
being
of the
a
water
fucking
won't
idiot.
No,
matter.
he's not.
The water
No,
is
he's not.
65 degrees. The water is 65
And?
degrees in both pictures.
And?
You know why?
And?
It's always 65 degrees.
All right, so
And?
you're agreeing with me. The temperature of the water is the same. Doesn't matter.
But what
It's the
happens
temperature of
in
the air that
hold
the water
on,
that
hold on,
evaporates.
hold on. Now, let's say one's a 60 degree. Let's say the blue picture is a 60 degree day. Matches the water temperature. So you would think that gradient will be such that it goes down. It's greater as it goes down, and the water's not affecting the air because it's already the same temperature, right?
You
Now
don't
the
look
one
at
on
the
the right,
water, bro. You look at the air from the top and
yes,
bottom.
we already agreed that the air is the same temperature as the water on the
Yeah,
left.
the water temperature doesn't matter.
Right. So we have a gradient that's based on that day and that
Wow.
temperature of
Okay.
You
65
don't
degrees.
check the gradient between
Hold
air
on,
and
just
water. You check
stop.
the gradient within the air itself.
Yes, right. We're not saying that. So the water's not affecting the air because it's the same temperature. That's all I'm saying.
No, because you're not looking through the fucking water.
Stop it. Just Don, you're not helping. Just
Don-
give
Don-
you're
now
being
we
an
know.
idiot.
It's the water
I don't know
is the
why he's
same
looking at the
temperature as
gradient
air.
of the
Nothing
water
changes.
and air.
Stop it.
Yeah,
Doesn't make
yeah.
sense.
You're not
Stop
listening
it.
very well,
Let me
Tanner.
finish. Let me finish my point. You can blab all you want. So the left, we have the same temperature, air and water, both 65 degrees. There we go. Now we go to the right picture. That's a 90-degree day because I was there that week. It was very warm and muggy. All right, and the water's still. Now we have a gradient that's going to
Just
be
pulling these
different.
numbers out of his ass.
We have now a cold water because the water temperature didn't change against a warm air. That's going to change the gradient. Would you not agree?
What's
Poe?
the temperature above?
90 degrees that day.
No, above. So at the water surface, like right above the water, there's temperature, and then as you go up, there's different temperature, right?
Thank you.
Yes.
He's killing you, Zanuck. Killing
No, he's
you.
not. He's
So
making my
what's the
point.
differential
He's
of
making
the
the point.
temperature of the air, not the water?
He's
Don't
making
worry
the
about
point.
the water. We agree the water is the same regardless. So what's the temperature of the air from top and bottom?
Now what happens is that particular picture on the right shows a 90-degree day, but the air close to the surface, because we have 65-degree water, cools the air above it, making it slightly more dense. This is why you get downward refraction, because the gradient
Hold up, you already admitted
increases.
the photo on the left is more dense.
Increases. It increases more than the left picture because the left picture, the air is the same temperature as the water. We just have
Okay,
a
now you're
pressure
backpedaling, Zanuck, because before you said the
I'm
left
not
is more
backpedaling.
dense.
I'm not.
And
I'm
now you're
telling
saying
you
because
exactly
of the temperature
what's
of the water,
happening.
the
You're
right
not
is more dense,
understanding it
even though
'cause you're
it's
a
more
Poe.
clear.
Because you're a freaking percentage.
You're contradicting yourself. For
I'm
5
not
minutes ago,
contradicting
bro.
myself at all.
Which
Not
one's more
one
dense?
bit.
The one on the left or the one on the right?
The one on the left is more dense.
But you just said the temperature of the water is causing the one on the right to be more dense.
Right at the surface, yes.
Oh wow! I swear to
Because
God.
it's colder. Doesn't colder make things more
Zanuck,
dense?
you really should slow down and ask more questions, Zanuck. When someone tells you you're wrong, you should ask them why.
So the one on the left is more dense, except for the one on the right being more dense at the surface.
Would you not agree that the 65-degree water meeting up against the 90-degree air would cool some of that air near its surface? Yes or no?
I would agree. Yeah, if that was
And if it's
those
cooler
numbers were
at the
accurate,
surface,
that
would it
would
be more
cool,
dense?
have a little bit of a cooling effect.
Would it be
Yes.
more dense than if it wasn't cool? Let's say the water suddenly was hot tub. It was all 90-degree water. Would that air above it be less dense or more dense in the second scenario?
What are those two scenarios? One is 65
As
degrees.
it is, 65
water
degrees
to
and
90
water's
degrees
90,
air.
and the air is 90 degrees above it. Would the air right above the surface, if that water suddenly was instantly warmed to the same air temperature, 90 degrees, would that air above it be less dense or more dense?
Yeah, ignoring any other like
Nothing else
temperature, pressure changes, you would expect it would be a little bit more dense because of the cold water.
Okay, so there you go. So now you just told me that the air mass above it has a area near the surface that is more dense, disproportionately more dense than the left picture, which wouldn't have any effect on that air mass at all. It would be strictly based on pressure.
There's something you have to be cognizant of. One though,
I'm
we already
cognizant
have
of
this
all.
picture on the left showing that it's more dense. Number
What
two,
do you mean
you're
showing
making
it's
up
more
these
dense?
numbers. These
We
numbers
already
are
agreed.
arbitrary.
We already agreed. We already agreed it's more dense. Don't go back.
Yeah, the one on the left is more dense.
Right.
It's
We're talking about the
observably more
density
dense.
gradient. The light does not bend through denser medium. That doesn't make light bend. It has to be a gradient.
And are you saying there isn't a gradient there? Do you have the temperature from the
There's
top and
always- doesn't
bottom?
have to be.
Do you have any refractive
Yes,
data from
we
above
have
and
the
below?
What,
temperatures those
Xanax?
days.
That has to be a change, not a gradient.
No, it has to be a gradient.
No, it has to be out change.
It has to be a gradient.
You are
and
the
you
dumbest
also need
motherfucker.
an angle.
Oh my
You
god.
also need an angle.
Yell louder there, Captain Rapey.
Yeah.
Zanik, do you have any data suggesting that there is no gradient on the one on the left?
There's always going to be a gradient. We talked about this at the very beginning. That's always
No, but less of a gradient. You're saying it's less of a gradient.
Less of a gradient. Why?
It's ubiquitously more dense.
There has to be.
Do you have temperature
It doesn't
readings
matter
from this?
if
Hold up.
It
Hold up. Do you
doesn't
have temperature
matter.
readings from the observer point and the rig, or from the surface of the water to the top of the rig? Do you have any kind
if you're a pilot,
different temperature
if you're
readings?
flying, let's say if you're flying airplanes, you understand what density altitude means, right?
Density altitude. I'm
What
guessing
does
it's
that
an
term mean?
altitude, like a estimation of altitude based off of density or pressure.
It's how the airplane's going to react in equivalence terms. So the density altitude says that if you're flying at 7,000 feet, but the air is actually, because of the temperature, it's acting like it's 10,000 feet, so it's less dense. So we know that this picture on the left is more dense. We already agreed to that. On the right, though, because the water's still cool and the air is warmer, we know that there's an area
I don't
near
know
the
this
water
stuff.
that'll be a
You're just saying
greater
that.
gradient. There'll be a disproportional change in the gradient versus the left picture. That gradient differential is what causes refraction. Do you not understand that?
Do you have
Think
any
about the
data to
yes
suggest
stream
that's actually
also.
warmer
how
on the one on the
refraction
right,
works.
or do you have any data whatsoever
don't
aside from
forget the
arbitrarily
yes
putting up numbers from your ass?
Wait, percent. Do you have any data? Because you were saying that the one on the
All
left
I'm doing is looking at the
definitely more
image.
dense
It's
because of how it looks, but that's
Yeah.
not like that's not
Yes, always there.
not an accurate.
No, it's completely
kind of
accurate. You can tell that
measurement.
there's more opacity,
Pokemon don't
more
need facts.
density
He's just got to say it.
from on the image of the left. You
It's
can
not
tell
a
that.
fact though. That's just
All-
you
all
saying that because
Pokemon
of how
has
the
to
color
do-
is.
Why else
Do you
would it be
understand
washed
that
out?
the yes stream is against the globe model?
Come
Why would
on,
the lighter
Pokemon don't
colors
need citation.
be washed
He
out and the
don't.
dark
He don't
colors be
have
washed
to
out?
bring
Shut
citation.
the fuck up, you snake snitch! Nobody wants to hear snitches talk. Y'all continue
Who
the
is
science,
talking?
please.
Who is
Please,
talking?
science.
Oh, Captain
please
Rapey,
continue
calm down
science.
there. Scream louder.
If it
Please.
was me, I was moving.
Don, go ahead and take a minute or two to calm down, sir. Okay, thank you.
Some autistic screeching over here.
Everybody
Talk
else,
about the facts.
hey,
Someone else
Just
take over.
let us talk about the facts. Okay.
Flat
Just
earthers love
relax.
facts. Go ahead. Bring
Yeah.
up the facts.
We have a pattern of yes streams.
Yeah.
And it has a perfect pattern over flat Earth, but it's all over the place if you try to make it over your global fantasy Earth. It